Hello students, welcome back to our channel Diksha Karnataka. So your NEET exam is approaching. So in this video, we'll be discussing the top 30 questions from one of the very high weightage topic, that is chemical bonding. So I'll be discussing some important questions from where you can expect questions. So there are different topics in chemical bonding which you must focus on, right? So let us see the first question. So the first question is first few questions are on the topic covalent bond, electrovalent bond, lattice enthalpy, octet rule. So based on these topics, we have taken some questions here. So the first question is, which one of the following molecules contains no pi bond? Okay, so this is very easy question. You know the structure of SO2, NO2, CO2, H2O. Structure is like this. It has no pi bond. So the correct answer for this question is option number D. Now coming to the next question, which of the following is electron deficient? So we know CH3 whole 2 is CH3 whole 2. This is electron full, there is no deficiency here. SiH3 is also correct. BH3, if you see, we have the structure like this, right? So if you know, the structure of BH3 is somewhat like this. So here there are actually 6 electrons, so the boron is electron deficient. So the correct answer for this question is option number C. Now coming to next question. So this is somewhere related, like we have this one Cl, okay, and one metal and F. So what has happened here is this C and I, okay. So now this bond has broken and this bond has formed, okay. So now the question is, which metal, okay, will have this reaction faster, okay. So that means the bond has to break easily, okay. It has to be an ionic bond so that it can break. Now if you know, this one is highly electronegative, right? So if we take a highly electropositive element, then the bond can break easily. So if you see, these are all group 1 elements: lithium, sodium, potassium, and then rubidium. So rubidium is highly electropositive, fluorine is highly electronegative, so bond can break easily. So with that metal, and the size is also, the bond will be unstable due to the size difference. So the correct answer for this question is option number D. Next, this is the most important part, bond parameters and dipole moment, very important part, and VSEPR theory, right? So we'll be discussing few questions from here. Which of the following is non-polar in nature? So non-polar in nature, if you see, we have CH2O. If you draw this one, this is the structure of COH. Then SbCl5, okay. So this is a polar molecule because oxygen is there. SbCl5. Sb is from nitrogen family. 5 electrons are there in the valence bond, in the valence shell, and 5 bonds have to be formed. So the structure of this one is trigonal pyramidal, okay. This is trigonal pyramidal. So here, since the bonds are cancelled, okay, the dipole moments are cancelled equally in both the directions, it is non-polar in nature. So the correct answer for this question is option number B. Now next question, which of the following set of molecules will have zero dipole moment? Okay, so zero dipole moment will happen in those cases where the dipole moments are completely cancelled, okay. So now we can see this example, boron BF3, okay. BF3, if you see, the structure is like this. So this is a non-polar molecule because the dipole moments cancel each other, okay. Then hydrogen fluoride. Hydrogen fluoride is having dipole moment, so this option will be a polar molecule, so we can eliminate option number A. Now if you see next one, nitrogen trifluoride, NF3. NF3 is sp3 hybridization, right? So this molecule is not, it is a polar molecule because we have the the dipole moments in different direction, it doesn't get cancelled. So that is why, because of this option, we can eliminate this one. Coming to this one, boron trifluoride, I have already explained, this is a polar molecule. Beryllium difluoride, that is BeF2. So this is a linear molecule, right? So here the dipole moments will cancel each other. So this can also be a polar molecule, non-polar molecule. Carbon dioxide structure, if you see, this is carbon dioxide structure, linear structure. So this can also be have zero dipole moment. And then 1,4-dichlorobenzene. So if you see this one, 1,4 and dichlorobenzene. So this one is also getting cancelled, right? So the correct answer for this question will be option number C. Next one, which one of the following pairs of species have the same bond order? So for calculation of bond order, we know a trick, right? That is, if bond order is, if the total number of electrons is 14, bond order is 3, 13, 2.5, 12, it is 2, 11, it is 1.5, 10, it is 1, right? Similarly, this side also we can have 2.5, 16 will have 2, 17 will have 1.5, 18 will have 1, right? So there is an exception for this one. Other than that is carbon monoxide. So except this, it applies to all. So now you can see here, just calculate the total number of electrons. Wherever the total number of electrons is same, their bond order will be same, right? So nitrogen is 14 and oxygen is 16. So this is cannot be same. CO and NO. CO is 6 plus 8, 14. This one is 7 plus 8, 15. So this is also incorrect. Now if you see this one, O2, 8 plus 8, 16. And this one is 7 plus 8, 15 minus 1, that is 14. So this is also incorrect. Now if you see this one, Cn minus. C is 6 plus 7 plus 1, right? So that is 14. And this one is also 6 plus 8, that is 14. Okay, so both of them will have bond order of 3. So the correct answer for this question is option number D. Very easily you can solve this question. Next, which one of the following molecules CH4, NH3 and H2O, which of the given statements is false? Okay, so we have to consider the following statements and they are false. So CH4, NH3 and water. So let us just first see their structure. We have this one CH4, then we have NH3 and then we have H2O. Okay, so you can see both, all the three are sp3 hybridized, but here there is no lone pair, here there is one lone pair and here there is two lone pairs. Now the HCH bond angle in CH4 is larger than NHN HNH bond angle in NH3. Yes, that will be correct here because of lone pair bond pair repulsion. What happens? This bond comes closer and the bond angle decreases. Here there is no repulsion, so bond angle will be more. First statement is correct. We have to find the false statement. Okay, next one. The HCH bond angle in CH4, the HNH bond angle in NH3 and HOH bond angle in H2O are all greater than 90 degree. Yes, this is correct because the bond angle should be somewhere around 109.28, right? So it will decrease, but it will not decrease as like it will become less than 90. Okay, so all will be greater than 90 degrees. So this statement is also correct. Now coming to this statement, the HOH bond angle in H2O is larger than the HCH bond angle in CH4. So you can see here, due to repulsion, lone pair repulsions are maximum. So there is my repulsion here. Due to this repulsion, these bonds will come closer. So the bond angle will decrease. So if you remember, the bond angle is somewhere around 104, somewhere around. Now this one is 109. So this bond angle will be more than this bond angle, but the statement is telling other way. So the incorrect statement is option number C. Now if you see here, the HOH bond angle in H2 is smaller than the HNH bond angle in NH3. This is also correct here because one lone pair is there. Here two lone pairs are there, so repulsions will be more. Okay. So next question, which of the following molecules has the maximum dipole moment? Okay. So now in CH4, if you see, the structure is like this, tetrahedral. NH3 structure is with one lone pair, 3 hydrogens we have. Okay. NF3 structure is with one lone pair, 3 fluorines. And with CO2, the structure is like this. Okay. So now if you see here, the question is about dipole moment. This is a linear molecule, dipole moment will get cancelled. Okay. Now in this case, in NH3 and NF3, the dipole moment directions for fluorines are is towards the more electronegative atom, and here it will be towards the lone pair. Now if you see here, these are all towards one direction. Okay. So that is why the dipole moment of NH3 will be greater, because all the dipole moments are in the same direction. Okay. Here if you see, this is in this direction, these three are in this direction. Okay. So the correct answer for this question will be, option number B, that is NH3. Okay. So the correct order of increasing bond angles in the following species. So let us see first the structures properly. We have Cl2O. If I draw this structure, this is Cl2 with 2 lone pairs, right? Next we have ClO2. So we have O, Cl at the central and So here we will have the Cl at the center and we will have O2 and we are left with one lone pair and one free odd electron. Next is the structure is ClO2 minus. So this is like this. It has two lone pair, right? So now if you see this one, the here only one lone pair is there, so repulsion will be less, so bond angle here will be greater. So ClO2 will have the highest bond angle, so we can eliminate these two. Now if you consider these two structure, right, here if you see oxygen is more electronegative, so what it will do, it will pull the electron towards itself, right? So when it pulls the electron towards itself, the bond angle will decrease, right? So that is why ClO2 minus will have the least bond angle, then Cl2O and then ClO2. So the correct answer for this question will be option number D. This is important question. Please remember this one, these structures and the formulas here. Now coming to next question, the correct order of increasing bond angle in the following triatomic species. Okay, so let us see the structure and try to draw them. NO2 plus. See, nitrogen has 5 valence electron, 1 plus is there, means we can say 4 valence electrons are there. So nitrogen with 4 valence electron will give you this structure, right? So this is your sp180 linear molecule. Now coming to NO2 minus. NO2 minus is nitrogen is having 5 electrons in the valence and 1 plus electron, that is 6. 6 electrons with 2, we will get like this a bent structure. Okay. So now coming to nitrogen with 5 electrons, so the structure here will be, we will have N, we can draw here like this, and one odd electron, right? So now if you see the structure carefully, here it is a linear molecule. Like linear molecule will have the highest bond order, so NO2 plus will be the highest bond order, right? So we have only that one option here. Okay, so let us, but we will check other compounds also. Here it is NO2 minus and this one is NO2, right? So now if you see, so first of all, because of the linear molecule, this will have the highest bond angle. So from the options we have already seen that option C will be the answer. Now if you see this one, NO2 minus and NO2, since there is a lone pair here, there will be more repulsion. Due to repulsion, these bonds will come closer, the bond angle will reduce. Here since only odd electron is there, so that repulsion will be less, so the next bond angle order will be NO2. Okay, so this is also an important question. Okay, now let us see the next question. The correct order of bond length among CO, CO3 2 minus and CO2. Okay, so this is important question again. Bond length and bond order, what is the relation? If you know, bond order, okay, is inversely proportional to bond length, right? So now if you see the structures here, CO structure, CO is having a triple bond. Okay, CO3 2 minus is structure is like this. Okay, and then we have CO2, right? So now if you see here, CO is a triple bond, so bond order is high. Bond order is high means bond length will be minimum. So CO will be having the minimum bond length, so we can eliminate these two options. Okay, now if you see here, CO3 2 minus and CO2 double bond. So here it is a double bond, but here it can be like this is in resonance. Okay, so when it is resonance, it is not a purely single bond or a purely double bond. Okay, so after this I can say that this is single and double bond, is the bond or bond length will be in between single and double bond, but here it is purely double bond, so after that it will come CO2. Okay, and the highest bond length will be for CO3 2 minus. So the correct answer for this question will be option number C. Next, the electronegativity difference between N and F is greater than the between N and H, yet the dipole moment of NH is larger than NF3. This is because, so just now we have discussed this concept. In NH3, all the dipole moments are in the same direction. That is why the dipole moment increases. So you can read here, in NH3, the atomic dipole and the bond dipole are in the same direction, whereas in NF3 they are in opposite directions. Okay, so the correct answer for this question is option number B. Next, the correct sequence of increasing covalent character is represented by, okay, covalent character. So we know this is from your Fazan's rule, so you should remember for covalent character, okay, the two things that you should remember is cation site should be small, okay, and anion site should be large. These two things we have to remember. Now you see in these all the options, the anion part is same, okay, so we need not consider the anion part, we have to consider only the cation part. In cation part, what is there? Lithium, then beryllium and sodium, right? So more, the smaller, more will be the covalent character. So you can see beryllium is the smallest one, so its covalent character will be the small, like more. So BeCl2, BeCl2, we can eliminate these two options. Now if you see after beryllium, what will be the size? Lithium. So next will come lithium, and the largest one will be Na, next one will be Na. So the correct answer for this question is option number C. Next, in PO4 3-, the formal charge on each oxygen atom and PO bond order respectively are. So PO4 structure, if you know, this is the structure of PO4 3-, right? Sorry. So the structure of PO4 3- is PO4 3-, right? So now if you see here, the total, so how many resonating structures we can draw like this? So I can draw one more structure like this just due to resonance, and one more we can draw like this, right? And one more I can keep on this side, that is P double bond O here, and we have O minus here, O minus here, and O minus here, right? So now if you see, there are total 5 bonds and 4 structures, right? So the bond order will be, in such cases, how to solve? The bond order is equal to number of bonds, okay, divided by number of structures, okay. So I'll get 5 is the total number of bond, structure is 4, so that is 1.25. So we can eliminate these two options, okay. Now about the formal charge on the oxygen atom. So now if you see, to calculate the formal charge of all these oxygens, you can see, let us just calculate for this one, okay. So this is -1, this is -1, this is 0, and this is -1, right? So now you have to calculate the average, okay. So the total charge is -3, and it is on 4 oxygen atoms. So -3/4 will be around 0.75. So the correct answer for this question is option number C. Once again, I am repeating that if you calculate by formal charge formula also, you will get -1, -1, 0, and -1. So the total charge is -3. There are 4 oxygen atoms, so charge on each oxygen atom will be -3/4, okay. That is 0.75. Okay. Next question. This is one of the major topic that we have come, VSEPR theory. Lot of questions are asked from here. So let us see, amongst the following, which one of the following will have the maximum lone pair electron repulsion. So while doing these questions, we'll try to draw the structures also, so that it can be revised well. XeF2, 8 valence electrons are there, 2 are used in bond formation, so 8 minus 2, 6. 6 means 3 lone pairs. So 3 lone pairs and 2 bond pairs. So if you remember, we have this structure, right? So here how many lone pair repulsions will be there? 1, 2 and 3. So there are, in this structure, there is 3 lone pair repulsions. Now if you see ClF3, ClF3 is a structure, T-shaped structure. ClF3 has T-shaped structure, right? So here we have 1 lone pair repulsion. 1 lone pair repulsion. Now if you see I is I5, right? So this is the structure, right? So here we do not have any lone pair repulsion. Here we have lone pair bond pair repulsion. You can write lone pair bond pair, many are there. SF4 is your seesaw structure. So this is your SF4 structure, right? So I'm doing all the structures so that you can just revise it once again. This is very important topic. So here also we will have lone pair and bond pair repulsions, but no lone pair repulsions. So since here there is maximum number of lone pair repulsions, the correct answer for this question will be option number A. Next, this is very easy question. PCl5, you have to just match with them. PCl5 is trigonal pyramidal. I think by this time you have remembered it. PCl5 is trigonal bipyramidal, so A is 4. We can eliminate these two options. SF6 is octahedral, so B is 3, so this is also there. BRF5, 7 and then 5 bonds, so it will be square pyramidal, so C is 1. And D, BF3 is trigonal planar, D is 2. So the correct answer for this question is option number D. Next, identify the wrongly matched pair. Okay, SF6 octahedral correct, BeCl2 linear correct, NH3 trigonal pyramidal is correct, PCl3 trigonal planar is wrong because PCl3 has one lone pair. So this is also trigonal pyramidal and not trigonal planar. So the correct answer for this question is option number D. Next, identify the incorrect statement related to PCl5 among the following. Okay, the three equatorial, so first let us do the structures of PCl5. This is the structure of PCl5. Okay, so the equatorial PCl bonds make an angle of 120 degree with each other. Yes, this is the structure here, right? This is trigonal planar structure. So here the angle is 120 degree. This statement is correct. Two axial PCl bonds make an angle of 180 with each other. This is also correct. So if you remember, the one which is in the plane are called equatorial bonds and the one which are along the axis are called as axial bonds. So this statement is also correct. Axial PCl bonds are longer than equatorial PCl bonds. Yes, this is also correct. This is done to minimize the repulsion. Now PCl5 molecule is non-reactive. Okay. So this statement is incorrect. Why? Because of this elongation, the molecule becomes little unstable or there's strain in the molecule. Okay, so that is why what happens, it can be more reactive or it is more prone to reaction. So the incorrect statement for this is option number D. Okay. Next, the species having bond angle of 120 degree is, so this is very simple, sp2 hybridization. BCl3 is having sp2 hybridization, right? So the correct answer for this question is option number A. Okay. Next, among the following, which one is a wrong statement? Okay, so let us see here. SeF4 and CH4 have same shape. SeF4, that is, if you see, it has 6 valence electrons. 1, 2, 3, 4, 5, 6. So 4 have formed bond. So if you see, this is the structure. Okay, this is the structure. There is only one single bond, one lone pair. Its structure is seesaw structure. Okay, and CH4 is tetrahedral. So the correct answer for this question will be option number A because their shapes are different. So let us see the next question. Which one of the following pairs of ions is isoelectronic and isostructural? Okay, so let us see here. First is your CO. So what are the compounds given? Let us check the compounds here. First is your CO3 2 minus. Next is your NO3 minus. And then we have ClO3 minus. Okay. And then we have SO3 2 minus. Okay. So first let us calculate the number of electrons first. Carbon is having 6 electrons. 6 plus for CO3 2 minus. Okay. So carbon is 6. Then 3 oxygen. So 24. And then 2 charge, right? So we have 32 electrons. Now coming to NO3 minus. Okay, so nitrogen is having 7, okay, nitrogen, and then again 24 and then plus 1. So this is also 32 electrons. Now we have ClO3 minus. ClO3 minus, here it is 17 electrons, right? Then plus 1, 18. Plus 24. So that is, we'll have 42 electrons here. Now coming to SO3 2 minus. So SO3 2 minus, if you check, sulfur is your 16, right? Then plus 2, 18 and then 24, right? So again we will have 42 electrons. So we can say that CO3 and NO3 are isoelectronic and ClO3 and SO3 2 minus are isoelectronic. So definitely these two options are impossible, okay, because they are not isoelectronic. We can check about these two options whether they are also isostructural or not. So if you see here CO3 2 minus, there are 6 electrons and then we have carbon is having your 4 valence electrons, 2 electrons are added, so 6 valence electrons, and then 6 valence electrons are forming 3 bonds like this. Just for showing, I am writing this structure, right? So it will have sp2 hybridization. Now if you see NO3 also has your 5 valence electron and 1 electron is present here, so total 6 valence electron, and then again, so we can draw this structure also like this. Okay, so NO3 minus. So these both are sp2 hybridization, both are trigonal planar, so they are isostructural. We can see for this one. So 8 electrons are there, and then we have 7 valence electron plus 1, that is 8 valence electron, and we have 3 oxygen. So we can draw the structure like this. This will be the structure here. Okay, so this is sp3 hybridization. And sulfur is also having 6 valence electrons and then 2 added 8 valence electrons. So this structure will also be like this, SO3 and 1 lone pair. This is also sp3 hybridization. So this structure and this structure, both the options are correct here, A and D. They both are isoelectronic and isostructural. Next, predict the correct order among the following. So it is about repulsion. So repulsions, if you know, we have lone pair, then we have lone pair, and then bond pair. So the correct answer for this question will be option number B. Very easy and simple question. Next, maximum bond angle at nitrogen is present in which of the following? Okay, so again you have to draw the structures and check maximum bond angle. So if you see NO2 plus, there are 5 valence electron, plus is there, so assume that there is 4 valence electron. In this 4 valence electron, we can draw like this, right? So you see this is sp hybridization 180 degree. So bond angle cannot be greater, like sp is having the maximum value. So the correct answer for this question will be option number A. Very simple one. Next, which of the following is not isostructural with SiCl4? So SiCl4 is like tetrahedral, that is sp3 hybridization, right? So if you see SCl4 will be having 6 valence electrons, and so the structure here will be like this, SCl4, right? So it will have, SCl4 will be having your square pyramidal, right? It is having 6, SCl4 has 4 bond pairs and we have 1 lone pair, right? So the structure is like this. Okay, so this is not similar to your sp3 hybridization. So the which is not isostructural, the correct answer is SCl4. But we'll check other options also. SO4 2 minus, so 8 valence electrons, 6 valence electrons for sulfur plus added 2 electrons, that is 8 valence electrons forming 4 bonds. So we will be having the structure like this for SO4 2 minus. So there is 4 sigma bonds, so it is sp3 hybridization. This is isostructural. PO4, if you see, there is again 5 valence electrons plus 3 8 valence electrons. Now in 8 valence electrons, if you do like this, we'll get the structure like this. Okay, so this is your again sp3 hybridization. Nitrogen has 5 valence electron, removed 1 electron, so it has 4 valence electron. Now if you draw, we'll get the structure as like this, which is again sp3 hybridization. So all these options are sp3 hybridization. This is incorrect, so correct answer for this question is option number A. Next, which of the following pairs of ions are again isoelectronic and isostructural? Okay, so we have which compounds? Let us see them. SO3 2 minus is there, NO3 minus is there, and then we have ClO3 minus, and then we have CO3 2 minus. Okay, so these are the 4 different types of compounds given. I think it is similar to this question which we have solved. Yes. Now let us do it once again. So if you see, S is your SO3 minus is your total number of electrons will be 16 plus 2 plus 24, right? So that is 42 electrons. This is 42 electrons. Now if you check for NO3, NO3 is your 32 electrons. This is also 32 electrons, and this is 32 electrons, and this is also 42 electrons. So we can have the combination of ClO3 and SO3. This combination is possible, and there is SO3 and NO3. These are not isoelectronic, we can eliminate. CO3 and SO3, these are also not isoelectronic, we can eliminate. ClO3 and CO3, these are also not isoelectronic, we can eliminate. Structure I have already explained in the previous question. The correct answer for this question will be option number B. Next, you have to calculate the planar structure. Which of the following molecule will have a planar structure? So nitrogen has 5 valence electrons, right? So if there is 5 valence electron and 1 electron is extra, so total valence electron is 6. Now if I draw the structure of this one, 6 valence electrons will form 6 bond with oxygen with a charge of negative here. So the total number of sigma bonds is 3. So the hybridization is sp2, right? So the here the shape will be trigonal planar. Okay, so the correct answer for this question will be option number A. Okay. Next, which of the following is a polar molecule? So polar molecules are those molecules where the net dipole moment should not be 0. So if you see BF3 structure is trigonal planar. It is like this, and the net dipole moment gets cancelled. So this is non-polar molecule. Okay. Now if you see SF4 has a seesaw geometry. The structure is like this. We have here 4 fluorines and we have a lone pair here. The dipole moments do not get cancelled here. So this can be a polar molecule. So let us check the other options. SiF4 is tetrahedral. So that is why this will also get cancelled. So this is also non-polar. And in XeF4, Xe has, like xenon has 8 valence electrons. 4 is used in bond formation and we have square planar structure for this one, right? So the XeF4 structure is square planar with this lone pair will get cancelled, this dipole moments will get cancelled, and all the fluorine dipole moments will also get cancelled as they are in opposite direction and equal magnitude. So the correct answer for this question will be option number B. All other options are your non-polar molecules. So let us see next question. XeF2 is isostructural with. So what is the structure of XeF2? 8 valence electrons, 2 are forming bond and there are 3 lone pairs now. So the structure will be linear. Okay. XeF2 will have a linear structure here. Now if you see SbCl3, so this is your pyramidal structure. Okay. Then BaCl2 is your ionic compound, so we cannot consider this one. Now TeF2 will be bent molecule, right? Very similar to your water molecule. So the structure will be like this. We'll have Te, then F and then 2 lone pairs. So this is bent molecule. So this cannot be the answer. ICl2 minus. So I has 7 valence electron. Plus 1, you can take 8 valence electron. So in 8 valence electron, it has formed bond with 2 and we have 3 lone pairs here. Okay. So this one will be isostructural with XeF2. So the correct answer here will be option number D. Next question, which of the following species has a linear shape? Okay, so if again you have seen this option before, NO2 plus, nitrogen has 5 valence electron, plus charge is there. So we can say like 4 valence electron. Now this one will form bond with 2 oxygens like this. So the hybridization is sp 180 degree and the shape will be linear. So the correct answer for this question will be option number C. Next, in which of the following the bond angle is maximum? Okay. So first let us see the structure here. For bond angle to be maximum, there should not be any lone pairs. Okay, if lone pair is there, repulsion will be there and bond angle will decrease. So if you see NH3 structure, this is pyramidal. We have 3 bond angles here, right? So this is having a lone pair. NH4 plus is tetrahedral without any lone pair. So the structure here is, it is a perfect tetrahedral, NH4 plus. Now PCl3 is also having lone pair with 3 chlorine bonds. SCl2 is similar to your water molecule or the bent shape with 2 lone pairs, right? So since NH4 plus has 0 lone pairs, there the bond angle will be maximum. So the correct answer for this question is option number B. Okay. So these were the top 30 questions from your chemical bonding and molecularity chapter. You can expect similar questions in your NEET exam. Okay. So if you have found this video helpful, please like, share and subscribe the channel. Thank you.